In the universe, death is usually final. When a star dies, it typically fades into a cold, white dwarf or collapses completely into a black hole. But sometimes, there is a middle ground, a purgatory. The star dies, but it refuses to vanish. It refuses to fade. Instead, it becomes something terrifying. It becomes a neutron star. It is the zombie of the cosmos. It is a city-sized atomic nucleus spinning at the speed of a kitchen blender, screaming radiation into the void. It is the most dangerous object in the universe that you can still technically touch. To create a monster like this, you need violence. It begins with a supernova. A massive star runs out of fuel and explodes. Gravity instantly crushes the core. Now, if the star is too heavy, it keeps collapsing until it creates a black hole. But if the mass is just right, the collapse hits a wall. The pressure becomes so intense that the subatomic particles are forced to merge. Protons and electrons are smashed together until they fuse. They become neutrons. Shutterstock. The empty space inside the atoms is squeezed out. The star stops being a gas. It becomes a solid ball of pure nuclear matter. The result is a problem of scale that the human brain struggles to comprehend. Imagine taking our sun. It is massive enough to hold 1 million Earths inside it. Now take that entire mass and crush it. Crush it smaller than the Earth, smaller than the Moon. Crush it until it is only 12 miles wide. You have fit the mass of a star inside the limits of a single human city. If you replaced the sun with a neutron star, it would be a tiny, invisible dot. But it would still have the gravity to keep all the planets in orbit. This compression creates a density that defies logic. On Earth, a teaspoon of water weighs 5 grams. A teaspoon of lead weighs 50 grams. But if you could fly a spaceship to a neutron star and scoop up a single teaspoon of its matter, that spoon would weigh 1 billion tons. That is the weight of Mount Everest, fitting inside a teaspoon. If you dropped that spoon on Earth, it wouldn't just sit on the floor. It would punch through the concrete, through the crust, and fall straight to the core of the planet. Because of this density, the gravity on the surface is apocalyptic. Gravity here is 200 billion times stronger than on Earth. If you stood on the surface, you would be instantly crushed into a puddle of atoms, only 1 atom thick. Because the gravity is so strong, the star is a nearly perfect sphere. There are no valleys. There are no hills. The highest mountain on a neutron star is likely only 5 millimeters tall. But don't be fooled. To climb that 5 millimeter bump would require more energy than a nuclear bomb. What lies beneath the crust? As you dig deeper, the pressure forces the neutrons into strange geometric lattice structures. Physicists, seemingly hungry while naming them, call this nuclear pasta. First, you find gnocchi blobs of neutrons. Deeper down, they stretch into long rods called spaghetti. Finally, near the core, they flatten into sheets called lasagna. This is not a joke. This material is 10 billion times stronger than steel. It is the strongest material in the known universe. To break a piece of nuclear spaghetti would require infinite strength. But this object isn't just dense, it is fast. When a massive star collapses, it follows the law of conservation of angular momentum. Think of an ice skater. When she pulls her arms in, she spins faster. The core of the star pulls its arms in from 1 million miles wide to 12 miles wide. The rotation speed skyrockets. Some neutron stars spin 700 times per second. That is 42,000 RPM, faster than a kitchen blender. The equator of the star is moving at 24% the speed of light. If it spun any faster, it would rip itself apart. This spin creates a weapon. The star has a massive magnetic field. This field accelerates charged particles and blasts them out of the north and south poles. 2 beams of pure radiation shoot into the dark. Because the magnetic poles are not aligned with the spin, these beams sweep across the universe. It creates a pulse. On, off, on, off. We call these objects pulsars. They are the lighthouses of the galaxy. But instead of warning ships, they warn us of the monster in the dark. These pulses are incredibly consistent. They are more accurate than atomic clocks. We can use them to navigate. In 1977, when we launched the Voyager probes, we included a map on the Golden Record. It shows the location of Earth relative to 14 specific pulsars. We used the lighthouse beams to draw a map back to our home. If aliens ever find the record, they can calculate exactly where and when we lived, just by listening to the rhythm of the dead stars. But pulsars are not benevolent guides. Some are cannibals. Sometimes a pulsar is locked in orbit with a normal star. The radiation from the pulsar blasts its partner. It heats the star up. It strips the atmosphere away. Slowly, over millions of years, the pulsar evaporates its companion. It eats its mate to keep spinning. Astronomers call this a black widow pulsar. It is a relationship that ends in murder. If a neutron star is a zombie, then a magnetar is the boss of the underworld. About 1 in every 10 supernovae creates something rare. The collapse happens so violently that the magnetic field is amplified to impossible levels. A fridge magnet has a strength of about 100 Gauss. Earth's magnetic field is about half a Gauss. A magnetar, 1 quadrillion Gauss. It is the strongest magnet in the universe. It is 1 trillion times stronger than the sun's magnetic field. It is an object that should not exist. What happens if you get close? You don't need to touch the surface to die. The star reaches out to kill you. If you flew a spaceship within 1,000 kilometers of a magnetar, the magnetic field would be lethal. First, it would wipe your computer's hard drives. Then it would stop the electrical impulses in your nerves. Your heart would stop beating. You would die instantly. But if you got closer, it gets worse. The magnetism is so strong, it overpowers the chemical bonds holding your molecules together. You would simply dissolve. You would turn into a cloud of atomic dust. How does it dissolve you? By breaking the shape of reality. Atoms are usually spherical. The electrons orbit the nucleus in a cloud. But near a magnetar, the field squeezes the electron clouds. It compresses atoms into thin, needle-like shapes. Chemistry relies on atoms being round. When they become needles, they can no longer bond with each other. Water cannot exist. DNA cannot exist. Life becomes physically impossible because the building blocks no longer fit together. This magnetic field is not stable. It twists. It fights against the solid crust of the star. Eventually, the crust snaps. This is a starquake. It is like an earthquake, but on a nuclear scale. The crust might only shift by 1 centimeter, but because the material is so dense that 1 centimeter crack releases more energy in a split second than our sun emits in 100,000 years. It is a blast of pure gamma rays. Has this ever hit us? Yes, December 27th, 2004. A blast of invisible gamma radiation slammed into Earth. It came from a magnetar called SGR 180620. It was 50,000 light-years away on the other side of the galaxy. And yet, the blast was so powerful it blinded satellites. It physically expanded Earth's ionosphere. If that magnetar had been within 10 light-years of us, it would have destroyed our ozone layer and triggered a mass extinction. We were saved only by distance. The only thing more dangerous than 1 neutron star is 2. Sometimes binary stars die together. They become 2 neutron stars trapped in a gravitational dance. They orbit each other at speeds we cannot comprehend, whipping around hundreds of times a second. But this dance loses energy. As they spin, they drag the fabric of the universe with them. They get closer and faster and louder. They are locked in a death spiral. These objects are so dense that their movement doesn't just disturb the gas around them. It disturbs reality itself. They create gravitational waves, ripples in space-time. In 2017, we felt one of these ripples pass through Earth. Detectors at LIGO heard a chirp. It was the sound of space stretching and squeezing. We listened to the final millisecond of a dance that had lasted for billions of years. And then, silence. When they touch, they do not merge quietly like black holes. They shatter. This is a kilonova. It is 1,000 times brighter than a standard nova. The 2 stars smash into each other at a significant fraction of the speed of light. They don't just explode, they splash. Trillions of tons of neutron-rich matter are vomited out into the galaxy. And in this chaotic hot mess, something magical happens. For centuries, alchemists tried to turn lead into gold. They failed because they lacked the heat. Our sun cannot create gold. It can only fuse elements up to iron. To create the heavy elements, gold, platinum, uranium, you need neutrons, and you need violence. In the fraction of a second after a kilonova, the neutrons slam into atoms, building them up into heavy precious metals. A single collision can create a cloud of pure gold, equal to the mass of 10 Earths. Look at the ring on your finger, or the jewelry in your box. We value gold because it is shiny. We value it because it is rare. But we should value it because of its history. That gold was not born in the Earth. It was forged in the death scream of two zombie stars colliding long before the dinosaurs evolved. It drifted through space for eons before it became part of our world. You are not wearing metal. You are wearing the debris of the ultimate cosmic violence. You are wearing the corpses of stars.